Kia ora, Year 12. This is part 2 of question 9 from the May 2017 paper 32. And in this one, we're going to keep going with the vectors question we did earlier. So we have to now find the equation of a plane. And it's using the same line that we had earlier. So here's the vector equation of the line L. Now we're looking for the plane that goes through the origin and contains that line. So this question's got nothing to do with that point, so we'll just get rid of that. So what are we looking at? Well, we've got the origin here. What am I trying to do? There's the position vector of the origin. And here's my line over here. Now, to find the equation of the plane, there are a few different ways to do it, but you know that my favourite one to get the normal vector is to use the cross product. So to do that, we need to have basically two direction vectors. And what we're saying is that we know that all the points on that line are going to be in the plane. But if we think about the point here that we've got, well, we've got another point up here. We could use any point, but I'm going to use the position vector from L. So R is equal to 9, negative 1, and 8 plus mu times 3, negative 1, and 2. So we have got to find basically 3 points in this plane or two direction vectors, because what we're saying is that we know that all the points on that line are in the plane, but we also know that the line joining up the origin and this position vector, okay, but there's nothing special about that position vector, it's just very, very easy to spot. So the line between the origin and there, all of those points have got to be on the plane. And when you look at it like that, I think it's quite easy to see that my normal vector is going to be the vector that is perpendicular to both the direction vector of my line and the direction vector between the origin and this point here. Okay, so we have to find the direction vector. I'm going to do that here because you won't always be lucky enough to have one of the point you're given be the origin. So the first direction vector, I'm going to call U, comes from the difference of the 2 points. So 9, negative 1, 8, minus 0, 0, 0. And then my second direction vector, we've already been given, so that's nice. So that's 3, negative 1, and 2. So I'm going to now use the cross product method to get a vector that is perpendicular to both of those direction vectors. And I'm going to call that vector N, because it's going to be my normal vector in my plane. So we'll write it out like this. We'll put the I, J, and K down here. Actually, I'm going to do a slightly different notation. Sorry, being a bit slack here. So here we've got I times the cross product of those four. So it's going to be I times negative 2 minus negative 8. Now the thing to watch is that this column here is a negative. Right? We've gone over that lots in class. So if you're watching this and you're not in my class, you're thinking, man, she's slack. That's because we've done that 100 times in class. So we've got a negative here for the J component, and we're going to have this column and this column for my determinant. So we're going to go 9 times 2, 18, take away 8 threes are 24. Plus the last one, here's K, and we're working with this little block here, so it's going to be negative 9 minus negative 3. And that gives me my direction vector, my normal vector of 6i minus negative 6, so plus 6j, minus 9 plus 3, minus 6k. So we're just about finished. Writing that in column format, we get 6, 6, or negative 6. And so I'm going to use, instead of all the 6's, I'm going to use 1, 1, and negative 1. Right, so that tells me that my equation for the plane, which has to end up in this form, is going to have A of 1, B of 1, and C of negative 1. So X plus Y minus Z is equal to D. But we could have done this bit at the start because we know that the origin is on that line. We substitute that in. We get 0 plus 0, take away 0, equals 0. So my final answer is X plus Y minus Z is equal to 0. So there you go. Make sure that you're really comfortable with that method of figuring out the two direction vectors. This is a bit of an easier question because the origin is one of those 2 points, right? But in general, if we want to find the equation of the plane and we're really desperate, all we have to do is to find 3 points, 1, 2, and 3. And then we're going to use the direction vector between any pair of those, and then we're going to find the normal vector. Okay, right, so let me know if you've got questions about that. That's a really common type of vector problem, so you need to be very, very comfortable with it. Thanks for watching, and I will finish off with part C later on.